Okay, hi everyone, my name is Han Lin, and I'm gonna record for the question 5 of the homework 1. So let's begin. Okay. There are two methods. Actually, we don't have to care about method 1 because it's not related to the question itself. The question is, on the average, what is the number of tasks we need to do by the second method, so all we have to care is about method 2. But there is one condition that we have to take care of. It says that for one person, the test result is positive equals to 0.1. So let's just suppose P equals to 0.1. It refers to the test result is positive for one person. Then let's see the method 2. It says it divide 100 people into 10 groups with 10 people in each group. So it makes 10 people's blood and test that mixture. So the question is, what is the number of tests we need to do? So let's just set a capital K. It refers to the number of the test. But here we won't set is K equals to per person, because actually in the method 2 we divide people into 10 groups. So let's set the K equals the number of the tests for each group. So each group is actually 10 people. So let's find out what the K can be. It actually just can be two numbers. First, K can be 1, and the second K can be 11. They're just these two numbers that K can be. K cannot be other numbers actually. So for the K equals to 1 condition circumstance, it actually refers to that all the 10 people in this group are all negative. Because if all the 10 people in the group are all negative, then the test result is all negative, then they don't have to do another test, so the K will be equals to 1. But if one of them, either one of them, any one of them, anyone in the group is positive, then as the problem mentioned, if anyone in the group is positive, then they have to test 10 people's blood one by one. So that will be 10 tests and plus the initial one, then the K will be equals to 11. So after that, we can find the solution of the average number of tests we need to do. It actually, I think, is the definition of the expectation, but we don't have to, we haven't learned it by now, but we still have to do it in the same method. So let's just say that for the 10 people for each group, the average number it will equal to, like, we have to calculate into with the under the two circumstances. First, we have to consider the K equals to 1. So the K equals to 1. Then we have to use the probability of K equals to 1 times 1. That's the number of the tests that we have to do when K equals to 1, and it will plus the probability of k equals to 11, and then it will time the number of 11. So, but right now we don't know the probability of pk, don't know the probability of k equals to 1, we don't know the probability of k equals to 11. So let's find out next. So the probability of k equals to 1, it actually means the probability of like all the 10 people in the group are all negative. So let's just take it. So that means we will use the p equals to 0.1 is positive for one person. So if all the 10 people in the group are all negative, then it means that it will be 1 minus 0.1 and 10. So it's actually equals to 0.9 squared 10 times. Then we will have p k equals to 11. It's actually, I mean, anyone, so it's just 1 minus p k equals to 1 each. So it's 1 minus 0.9 10 times squared. So the average for term, so we can now calculate the average for term because we will just substitute the p k equals to 1, the p k equals to 11 into it. It's here. I will rewrite here. So the average for term 10 it will be equal to 0.9 10 times squared times 1 plus 1 minus 0.9 10 times squared times 11. So it will be equal to 11 minus 20 times 0.9 10 times squared. So this average for 10 people, the average number of tests for 10 people, but we do have 100 people in this 10 groups. So the final result for the average number of tests to do by the second method, we have to use this average for 10 times 10. So the final result will be 10 average for 10. It will be equal to 10 times 11 minus time times 0.9 10 times squared. Okay, so this is the final result of this problem. So that's all for the question 5. Thank you.